Scaling Ethereum has been one of the hottest topics within the cryptocurrency community for a while now. The network's transition to proof of stake opened the door for an array of different approaches. In this regard, zero-knowledge proofs, also known as zK-Proofs, are where all the rage is right now, but to many, this is still a very foreign concept. Today, Crypto Potato is joined by Gauram, a product manager and a blockchain researcher at StarkWare. He helps us understand what are zK-Proofs, why they're critical to overcoming Ethereum's existing limitations, and what StarkWare is working on to scale the network even further. My name is George, and welcome to another Crypto Potato podcast. As always, if you enjoy our content, please hit the like button as it helps us a bunch. Also, don't forget to subscribe to our channel with the notification bell on so you don't miss on any future videos. First of all, I'd like to start this off by thanking Kigal for agreeing to do this. And today I'm joined with my colleague Max, so I'm sure it's going to be a very interesting conversation, especially given the nature of it and how many people are currently talking about what you guys are doing. But before we dive into it, let's start with a brief introduction of yourself. You have a computer science degree with a focus on bioinformatics. So tell me, how does one end up in crypto?
Yeah, so that's a tricky one. Actually, so first off, I'm happy to be here. The bioinformatics part is I was basically tricked by my thesis advisor. He used to be a cryptographer. He was teaching at the Technion and then Tel Aviv University, and he was a student of Ron Rivest from MIT. That's Rivest, that's the R from RSA. And I was like, wow, sure that we're gonna do some cryptography research together, but he ended up shifting to bioinformatics, so I kind of followed along.
What is bioinformatics though?
Yeah, I was gonna ask the same thing.
It's basically the intersection of biology and computer science. A lot of the recent advancements in biology, gene editing, if you've heard of CRISPR technology, it actually comes out of the computer science departments of the academia. So I was doing some research in gene editing, but it was interesting at the time. I haven't touched it since. Maybe I will get back to it again in the future.
Human bodies will be there later.
Yeah,
exactly.
And how did you end up in crypto?
So my background is technical. Like I used to be a security engineer doing mostly work in embedded systems. And my first exposure to crypto was somewhere between 2015 and 2016. I was studying computer science for my master's in Tel Aviv University with the same professor that then ended up converting me to bioinformatics. But he was a cryptographer, and together we sort of explored the academic research coming out of the Technion and Tel Aviv University in crypto. Back at the time, Zero Cash was a big thing, ended up turning into Zcash, the coin that still exists today. So we did some research on it together. We started a little crypto club in Tel Aviv University. But, you know, it was interesting, but back then it was more of like a side hustle, not something that I'd consider doing as a full-time job. And fast forward a few years, I moved to the US, lived in California for a few years. I got an MBA at Stanford University, and this is where I sort of got converted from being an engineer to being a product manager. So I did that for a few years. And a couple of years after graduation, it was 2021. I was working on something else that I ended up shutting down. And it seems like a good time to kind of see what's up with crypto again. The field looked dramatically different than 5 or 6 years before. And you know, I've always been very interested in this intersection between finance and computer science, and it looked like a good time to, you know, maybe try crypto as a full-time job. And I can talk about how I ended up in StarkWare. This is kind of a funny story. Like, I'm Israeli, and StarkWare is an Israeli company, but actually didn't know that when I first heard about StarkWare. I was following Vitalik's blog, and he put out this end of 2021. He put out this article called Endgame about the future of Ethereum and how it's going to scale. And this is the first time that I heard about zk Sync and StarkNet. So it sent me to this sort of long process of understanding what zK-Proofs are and what's the scalability problem in Ethereum. And that's how I learned about StarkWare. And I realized that I have a few friends who work there. So they made me basically move back to Israel, and the rest is history.
I'm curious. So you said you, when you were in Tel Aviv, still studying, you were doing a little bit of research on Zcash, ZeroCoin or ZeroCash, whatever it was back then.
Yeah, ZeroCoin was a paper, and Zcash ended up being the project, the coin.
Okay. And didn't that have some? I mean, isn't it built on like a zK-Proof technology? Did you have some exposure to it then?
Yeah. So and funnily enough, the paper was written by Professor Eli Ben Sasson, who ended up starting StarkWare 4 or 5 years later, which I didn't really realize when I joined StarkWare. But yeah, so a lot of like the privacy-related research in crypto has been coming out of the Technion and Tel Aviv University.
Okay, so the claim of StarkWare is that you guys provide scalability, security, and privacy. So walk us through how do you guys do it? What do you guys do? What is StarkWare, and how do you achieve that?
So actually, we focus on scalability. Ethereum provides the security, and privacy is not exactly our focus right now. I could talk about this a bit later, but we started with a privacy focus. But right now, the mission of StarkWare through StarkX and StarkNet is basically to scale Ethereum while enjoying the security of the underlying layer 1 chain. I think that maybe it's like first interesting to understand the scalability problem of Ethereum, like why is Ethereum not scalable enough?
Yeah, please.
So I think that many people refer to Ethereum as a distributed system, but actually it's more of like a replicated system, because all the nodes in the network do exactly the same job. Every node in Ethereum processes exactly the same transactions in the same block, and this is very different from truly distributed systems like the torrent network, where you download different chunks of the data from different nodes in the network. So in Ethereum, to satisfy like all the trust assumptions and trust requirements, all the nodes have to do the same thing. So by definition, this kind of puts a limit on the throughput of the system, because if we increase the TPS or block size above a certain threshold, we would start preventing the smaller nodes from participating. If I want to allow even like the tiniest computers to participate in the operation of the network, I have to limit the throughput. Otherwise, they won't be able to participate. So the first interesting thing to understand is that Ethereum is by definition restricted in its capacity. And I think that there are like various ways to solve this problem. One is to go and say, let's invent something else. Let's create our own layer 1 with our own parameters that could have a TPS that's as high as we want. And this is the approach taken by some other layer 1s. We decided to take another approach of scaling Ethereum from Ethereum and not getting out to another, like not creating another chain. So we started doing it by StarkX. I mean, should I talk about the?
No,
yes.
I just have a quick. So just to clarify that, because I think it's interesting. You know, people often refer to Ethereum as like the global computer, right? But in what you've just said, and I think how it actually does make sense to me. It's like the world's most inefficient computer. You know, it's every single node is doing the exact same task. So does that mean that then the power or the ability of Ethereum is really based on its weakest or like smallest node?
So exactly, like the throughput of Ethereum is restricted by the capacity of the smallest node that you'd want to still allow participating in the operation of the network.
Sorry, go ahead.
If we'd allow we'd allow only supercomputers to participate in operating Ethereum, we could end up with significantly higher TPS than we have on Ethereum today. This is, if you look at what's happening on Solana, for example, it's more similar to this, where you have like relatively like low amount of operators but they're all like very large computers, so they're able to process many transactions.
Right, but this in itself then sacrifices the distributed nature of the network, right? Because
exactly.
Yeah, right. So how do you guys fix that?
So the thing that happens with Ethereum is that all nodes have to rerun all transactions, because before zk there was no other way of trusting that someone else ran a computation with integrity. If I'm a node on Ethereum, I see other nodes reporting to me what they think the new state of the system should be. There's no way for me to trust them besides just rerunning the same computation that they just ran. And the magic about zero knowledge proofs is that it creates a new way, or like a new paradigm of trusting other entities without having to rerun the calculation that they just did, which is really a kind of, it becomes more mind-blowing as you think about it more. It's, I think, going to be revolutionary in many more fields other than crypto, but in the context of crypto, it could change things and improve things significantly, because when you introduce zero knowledge proofs, we didn't really define them, so we can do this in a second, but when you introduce zero knowledge proofs to a blockchain, you could have nodes that say, okay, I trust what other nodes are telling me without having to rerun their computation. Instead, I'm just going to verify this other thing that they provide to me called a zK-Proof. Verifying this thing is exponentially easier than running the calculation yourself. And I'd magically be convinced that no one cheated me, which is really what StarkNet and StarkX are about.
Yeah. Okay. So I think now is the best time to get into then what are zK zero knowledge proofs. And maybe I know I've been doing some research on this, and it's very difficult to find like a really one-to-one real world example or like analogy. But I wonder if you have some kind of general way of explaining this so that we can understand like what knowledge is and how that differs from information.
So, okay, I think the easiest thing to explain is what a proof is, outside of the context of zero knowledge. Like, what do we mean when we say a proof? So, if you, and the easiest example that we like to give is it's like a restaurant bill. You go to a restaurant, you finish your meal, and you end up like getting a receipt that says that lists all the items that you just purchased and then a total amount. So this is essentially a proof that the restaurant owner provides to you as a customer to show you that they ran the calculation of the total amount with integrity and that they didn't cheat you. Now, this is a very naive proof, because verifying this proof requires you to rerun the same calculation that the restaurant owner just ran. But it is still a proof. With a zero knowledge proof or a validity proof, and I'll touch on the difference in a second, verifying the proof is significantly easier than creating the proof. In the restaurant bill example, creating the proof is kind of like verifying the proof, because creating the bill is very similar to reading through the bill and doing the calculation yourself. But imagine that you went to the restaurant and you had like a real feast this time, and you ordered 100 billion items. So generating the proof would require the restaurant owner quite some time. But imagine that you could verify this proof just like in a second without having to rerun all the calculation. So this is basically like what zero knowledge is about: the ability to verify the work of someone else without having to rerun it yourself.
So, okay, actually, it's interesting that you gave an example of a restaurant. I'm not sure. Are you familiar with Douglas Adams' Hitchhiker's Guide to the Galaxy?
Somewhat. Like, I read it a long time ago.
Okay.
I gave a similar answer.
I read it a couple of years ago too, but as I was getting into zero knowledge proofs and trying to understand them, for the idea of the infinite improbability drive, and also that was what powered one ship to travel across the universe, and another ship was actually able to travel across the universe given like this whole situation where people are going into a restaurant and it's infinitely complex. You don't know when the reservation is going to be, you don't know how many people are going to show up, you don't know who's going to order, how much they eat of this, but like all of this chaos is going on until finally at the end the waiter brings the bill, and that's like the proof. And then once they have that proof, the ships are able to essentially travel to wherever they're going. So it's interesting to me to understand kind of like how that is when you have the proof, you have the map of like how everything should go there, you have the answer, but then like when you're trying to go back and or when you're transferring that over, I guess, saying, okay, I did this proof, I know how the path goes, and here's the receipt, you can check it yourself. My question is, I guess, still, how do you make that proof without including information?
Okay, so I said before, like zero knowledge proof and then validity proof. Actually two flavors, and those two terms, they refer to two different characteristics of what zk is. First, it gives us, as I said before, it gives us the ability to be convinced that someone ran a computation with integrity without having to run it ourselves. So if you think about asking someone to run a query on our behalf on some huge database, it would be really good if we could be convinced that they actually ran this query without having us like run it ourselves, right? It would save a lot of time. So that's about like the validity of a computation. The other component is privacy, or being convinced that someone ran something with integrity without having them reveal to us the inputs that they put into this equation, which is not what we're focusing on at StarkWare. It would become possible in the model of a layer 3 on top of StarkNet. StarkNet is a blockchain, and the same way that StarkNet extends Ethereum, we are going to allow other chains to extend StarkNet. And if you want to operate another chain on top of StarkNet and keep some information private, let's say that you have some DeFi protocol and you have some complex trading strategy, and you want to let your users hide their strategy while trading it according to it in real time. This is where privacy starts to get interesting. So there's like this balance between two things that you can achieve, or not balance, just like a duality. You can achieve those two things. Be convinced that someone ran a computation correctly without cheating, and also as someone who runs some computation, not reveal your inputs. But this is, again, like not what we're focused on at StarkNet.
So yeah, I guess as I was doing this research, preparing for this, I also realized how adjacent like mathematics and kind of like the very theoretical mathematics is to like this this sphere or this technology. And so maybe correct me if I'm wrong, but this is possible because these algorithms are non-deterministic, right? There could be multiple different ways to get to the answer, but in that way, if you have the answer, you don't need to know which path led you there. You just have to know, like, okay, you got here out of this many different, or out of however many different possibilities to get there. You have the proof that someone got there. Is that kind of along the right lines?
So I still haven't found like, it's funny, like there are many very complex things in math that have a simple intuition. I still haven't found the simple intuition for why zero knowledge proofs work.
Yeah.
But there is some, randomness in the process of verifying a proof, in the sense that why is verifying much easier than generating the proof? Because when you verify a proof, you just sample a relatively small number of places where the prover could have cheated. Mm-hmm. And if you see for yourself that they didn't cheat in those few places, it convinces you that with very high probability, the prover didn't cheat anywhere else. So there is some, you said not deterministic, there is some like probabilistic feature to verifying a proof.
Mm-hmm. Do you have
and,
any
and like you know, like many things in cryptography, you never know for sure. Like even
right.
when you like use RSA to encrypt something, you never know for sure. Everything that the only thing that you know is that there's a very tiny probability that someone could break your code or break your encryption or generate a zero knowledge proof that says that you did something correctly, but actually you didn't.
Mm-hmm. So maybe in that way, do you have any sense of like what that subset would be for like how much computing the prover would have to do to calculate the proof versus what the validators would do? Is it like validators, it's like 10% as much, or is it 1%? Any sense of that?
Significantly less. Like it's very like we've actually done this experiment at StarkWare. I think it was 2 years ago before I joined, and we took all of Reddit, like all of the posts on Reddit, and compressed them into one proof, and we were able to show that you can, like, generating this proof is hard, and we had to pay to put a significant amount of computing resources into it. But once the proof is ready, you could like very easily verify it even with your smartphone. So there, in zero knowledge systems, and in a system like StarkNet, we create kind of like two variants of nodes rather than the single type of nodes that you have in Ethereum. In Ethereum, all the nodes are the same. In a zk rollup, you have provers and verifiers. Provers have to be, like large computers. They put a significant amount of resources into generating those proofs, but verifying is extremely easy. Does this make sense?
Yeah. So that's kind of the solution to Ethereum's problem then, of that, it's only as efficient as its weakest link. Well, with with zk-Proofs, if the prover can essentially boil down the information so that then any verifier, if I can verify on my laptop or my smartphone, then it's just, I'm not slowing down the whole process. I'm just, I'm acting as the verifier. So maybe then we can just now get into kind of like the distinct roles. I know that the prover and the verifier, right? But the prover, before, they also need to have like the sequence, right? You said that StarkNet is a blockchain, right? So
yeah,
how does that work? And how does it go from like, transactions that are happening off the Ethereum main chain on StarkNet, you're making these transactions, and then somehow you're getting that to a prover that's then sending it to the validators on Ethereum. But what's kind of that process?
Yeah. So I mentioned two components before. Actually, I lied, and there are three. The provers and verifiers, but they're also sequencers. So a sequencer is the first kind of like your gateway to the network. Sequencers are entities that are able to take transactions and first check that they're legit, like they're signed correctly, they change the state of the network in a way that makes sense. They bought them into blocks, and then they send those blocks to the prover for proving. The prover sends the proof to Ethereum. Like right now, the way, and I'm jumping in between like theoretical zk and how things work on StarkX and StarkNet, because I think this is more interesting in our context. All of the like verifiers are actually Ethereum nodes, because the verification logic for StarkNet's proofs is written as Solidity code deployed to Ethereum. So right now, StarkWare is the operator of StarkNet's sequencers and provers, but Ethereum is the operator of the verifier by the nature of the verifiers being smart contract on Ethereum. And in the future, and this is something that we've started working on and also communicating to the world, our plan is to first decentralize the sequencers and then decentralize the provers. Like StarkWare as a company, we don't want to continue being like the maintainers of StarkNet forever. But we kind of skipped, defining, we're talking about what's StarkWare, what's StarkNet, and what is StarkX.
Right, yeah.
Yeah, I wanted to touch upon that. You mentioned StarkX. Can you explain what StarkX is?
Yeah. So, and I know that this is extremely confusing. Like the way we pick those names is kind of tricky, but StarkWare is the company. StarkX is our first product. It's an enterprise product that you have to sign a deal with us, and then you get access to a system that lets you do one out of a few things, like trade perpetuals, mint NFTs. That's the StarkX is the engine that operates projects like DYDX in the perps trading area, and Immutable X and StarkWare in NFT minting. And through StarkWare is actually one of the largest minters of NFTs. I think definitely on Ethereum, but I think also like overall in crypto. And through StarkX, we've processed over $800 billion. Like we're gradually like reaching the milestone of processing $1 trillion, which is, I think, quite incredible.
Yeah, it's no small amount.
Yeah, and you know, it also there's a lot of synergies between this and StarkNet because the underlying technology is similar. So now when we give the public access to StarkNet, we can say that this system has been battle tested with processing almost $1 trillion in StarkX. So StarkX is the first generation product of StarkWare, the company. And StarkNet is sort of like the next generation multi-purpose blockchain built upon the same technology used to operate StarkX. But in the StarkNet case, one, everyone can use it. We don't need to sign anything with us. It's just like a permissionless blockchain. Go figure out how to write smart contracts for StarkNet and deploy them. And two, our roadmap is to decentralize StarkNet completely. Like the long-term vision is that StarkNet is, you know, like a public good, like any other, like Bitcoin, like Ethereum. It's fully decentralized and it's not controlled by us.
What's what are the areas that you need to decentralize though? You mentioned, is that where the sequencer and the prover need to be decentralized?
Yeah.
Or is there more? Yeah.
So it's basically the sequencers and the provers. The verifiers are already decentralized because they are smart contracts on Ethereum. Which is interesting because it means that still today, StarkNet is operated as a centralized, soon to be decentralized, but right now it's a centralized system. And yet no one could cheat. Like the only thing that we could do as a systems operators right now is censor transactions. Not ideal, and this is going to be solved as the network gets decentralized, but we can't cheat. Like we can't steal anyone's money because eventually it's Ethereum's nodes that are not going to accept those transactions.
So that's okay. I guess that makes some sense because the sequencer, you know, it's taking information of things that are happening on the chain, right? Is that you know, on Ethereum, it's taking those transactions and then it's compiling them. And so it could censor, it could just say like, you're not going to be in this block, but it can't change those because the information, the underlying preliminary information is already being, you know, it's already happening on Ethereum's chain. Is that correct?
Yeah. Yeah.
Okay. So the kind of like the places that, you know, there could be, you know, like the sequencer could just say like, no, I'm not going to accept this. We're going to censor you. But even if that were to be the case, couldn't some other node or like, you know, the kind of the original Ethereum processes, wouldn't it still process those transactions anyway?
So the two, you know, like two steps here. First, you want to take a transaction and accept it into a proof. And then once the proof is generated, there is a set of verifiers that verify that this proof is actually correct. So where we can cheat right now is by not accepting someone's transaction. But we would never, even today, would never be able to create a proof for a malicious transaction. Let's say that, you know, you bridged some of your assets from Ethereum to StarkNet and did something with those assets. No one could take those assets from you. Like no one could, because this would require generating a StarkNet proof that says that those assets don't belong to you anymore. And you didn't send a transaction that sent those assets to anyone.
Okay, that's very interesting. So that's kind of where you're at now, but the plan, you know, your roadmap is to decentralize those. And how would that decentralization work? Like, how could you decentralize the sequencer? How could you decentralize the prover? I guess, especially the prover, it seems counterintuitive because with logic, it's kind of like a step-by-step thing. How could you split that up? Or is it not distributed? It's decentralized, kind of like how Ethereum runs, like each node is running the same thing. It's not giving like a torrent or something like where you're giving bits. Each node is giving a bit.
So first, I gotta say that this is like a very hot topic for discussion and research inside StarkWare right now. And I don't have all the answers. I can share, some of the internal line of thinking that we have currently, but maybe things will change. I think that distributing the work of the sequencer is easier than distributing the work of the prover, because the proving work is much more resource intense. Not everyone could be a prover. So the way I imagine it is that verifiers are going to be fully decentralized because they sit on Ethereum. So this one piece is solved. Operating a sequencer, again, is something that could be decentralized by some mechanism where every sequencer takes a turn. We've actually taken some inspiration from Aptos in the way they designed their PFT mechanism. They took a consensus protocol called Hot Stuff and iterated on it, and we did some adjustments to the protocol as well, which I think is really cool, like to see how quote unquote competing projects work together on the research front. So decentralizing the sequencer is possible. Decentralizing the prover might be harder. Like, I don't think that we're gonna have millions or hundreds of thousands of provers the same way there are hundreds of thousands of Ethereum nodes. This number is probably going to be a bit smaller, but we'd still want to allow anyone who wants to operate a prover to do it.
If I can go find a supercomputer, I could join.
It doesn't, maybe I'm sort of exaggerating here. It doesn't have to be a crazy supercomputer, but there has to be something more stable and more performant than your smartphone.
Right. I see. I just had one more, I guess kind of one more question on the tech side. And then you've mentioned a few things here that I want to get back to as well. And I'm sure George has more questions. But the name StarkWare, StarkNet, StarkX, it's all has Stark, right?
Yeah.
So Stark is it's different from Snark. Maybe you can tell us about those differences. And because Snark technology, correct me if I'm wrong, or the kind of like research and development of that is older. It kind of has its roots, papers in like the late noughts and early 2010s. But Stark technology is newer. Is that correct?
Yeah. So, like things work in the academia, researchers usually publish the work based on previous work. So Snarks came before Starks, but there's still kind of same area, like very very technical differences. Like Starks are post-quantum secure, and Starks don't require a trusted setup, which are two good features. Snark being earlier is a good feature for Snarks, because with cryptography and with mechanism where you put a lot of your assets and value, you want to be closer to the more reputable and more battle-tested technology. But the interesting thing is that through StarkX, I think that today Starks are actually more battle-tested than Snarks. Like, it's true that Starks came before, but since StarkX came into production, that's a system that uses Starks. In practice, we have a lot more assets being secured by Starks than Snarks today. So, I think that eventually I see Snark systems converging into Starks. The few advantages of Starks are relatively, I think marginal. But this is, like a pretty technical field that I'm gonna leave to the academics.
Sure.
I want to. Can I just, because I'm really not that familiar with the zk technology, but I want to attempt to dump it down to those who are just like me, not that familiar. So basically what I gather is Ethereum is a network of nodes. the network is as powerful as its weakest link, like the weakest node. And what you guys are doing is essentially dumping down the information that weakest node has to process, so that you don't have to have that much computational power on that node. Essentially,
exactly.
Right. And that's how, right. Okay. Then it's not as complicated as I thought. I mean, it is. I don't want to oversimplify it. Of course, it's really complex, but essentially that's the main principle that
No, that's a great, it's, I wouldn't say that it's dumbing it down. Maybe it's a much better and more concise way to say everything that we just said. Like with proofs, Ethereum nodes have to just process much less information.
They make it more succinct, right? So it's
that's the S in Starks, by the way.
Yeah, right.
Yeah.
So that's the S in Snark. The S in Stark is scalability, right?
You're probably right. Yeah.
Okay, but essentially they're two sides of the same coin too, because the more succinct that you can make that, the more scalable it can be. Yeah. So you mentioned, and thanks, George. That was a good, like, again, boiling it down to its kind of like what are the results? What do we want this? What's the technology doing? But you mentioned just a second ago about the sorry, give me a second.
Max,
so
Go ahead.
So you just mentioned that you were working with Aptos and kind of working together, building off of each other.
We're not working together. They published some research that we then we built upon it for our internal research.
Okay. So like, but they made their research public, and it's kind of like in a, it can help even their competitors, such as you. But I wonder the kind of the way that Snark technology is still being researched and developed. Do you think that there's like these so-called like zK wars? Do you think that, trying to build, like sticking to one design and trying to build that, to take market share, do you think that could hinder future kind of research and development?
What do you, when you say zK wars, you mean like the zK
like between
EVM versus non-EVM compatible thing, or?
Yeah, I mean, like a lot of L2 wars. I mean, you're not the only company or the only system that's trying to make, to fix the problems of Ethereum.
Yeah.
But everyone's doing it in a slightly different way. But does that kind of, the more market share, or kind of like stronger your technology gets, does that kind of block out what might be a better design that someone hasn't yet come up with, but like, could?
Yeah. So first off, I got to say that, like, internally, everyone at StarkWare is a lot more focused on, building what we want to build, rather than, going on wars with other projects. And I feel that this is kind of how things work with other projects as well. Like, you just want to do the best thing that you plan on doing. Like, you come up with a plan, then you execute on it. So that's how we operate. But I also think that scalability comes in many forms. Like, it's okay that there would be more than one scalability solution for Ethereum. I don't see, our competition as a threat to our market share, but rather, I think that the more scalable Ethereum becomes, we'd see more use cases and more ways to interact with crypto, and more builders coming to build things that they couldn't have built before. So it's true that there's some overlap between the way we're scaling Ethereum and the way other projects are scaling Ethereum. But overall, I think that everyone's mission is on making Ethereum more accessible to builders. So besides, it's more of like a game of let's expand market share together than a game of let's take market share from each other.
I see.
And go from a non-tech person perspective, I've read some of Vitalik's papers and a lot of his comments and thoughts, and he said on multiple occasions that he sees Ethereum handling tens of thousands of transactions per second through some solutions like the Ethereum developers themselves are working on. For example, sharding, right? So he's said on multiple occasions that if they implement sharding correctly, Ethereum will be able to handle a lot more transactions. Where does leave L2s, right? I mean, because there is a lot of talk on what happens to L2s if Ethereum becomes scalable enough on its own, for example, if they're able to solve their scalability issues on their own.
So first off, I think that it would be good. Like our mission is to scale Ethereum. So if it's not to build StarkNet or to build StarkX, it's to scale Ethereum. And if the Ethereum community comes up with a new way to scale itself, we would want to be part of this effort. I also think that this way or another, any system that would want to scale would have to embed some zk technology into it. And through what we've been doing the past years, we're in a great position to be part of this. We've been as kind of like a side hustle of StarkWare, we've been helping the Bitcoin community scale through zk. And there's an initiative that we're supporting for setting up Bitcoin nodes that sync with zk. So if that happens in Ethereum, I think that we'd love to support it. But I've heard the things that you say come out of the Ethereum community. I've also, in practice, we see the Ethereum community boosting rollups and through EIPs like 48, 44, they are embracing rollups and they're allowing rollups to operate more efficiently on Ethereum. So in practice, I think that what happens with the Ethereum development is that they're embracing rollups.
Can you perhaps dumb it down? What is a rollup? Like for someone who doesn't understand it, what is a rollup?
So every blockchain has a state, right? I have 5 tokens, you have 10 tokens.
Right.
We swap some tokens. So the next state would be, I have 0 tokens and you have 10. And a rollup is basically another blockchain that has the same state logic, same architecture of transactions that change the state. But the thing is that a rollup commits its state back to some underlying layer. So what do we mean by saying that StarkNet is a rollup is that we occasionally, quite frequently, commit the state of StarkNet into Ethereum so that we won't be able to do any, malicious stuff on StarkNet. Otherwise, Ethereum would just like call that on us. The reason to do it is that the place where the most amount of assets live is the most secure place. And right now, most of the assets are on Ethereum. So if we'd want to develop our own security mechanism, we'd have to convince people to move their assets from Ethereum to our chain, which I don't think that this is something that is doable today. I think that, and this might be like another hot take, I think that we're eventually going to converge into a world where there's one underlying layer. We're not going to have multiple layer ones, the same way that in the 60s or 70s, we had multiple internets, but now we actually have just like one internet. So I think that crypto is going to converge into this model. So a rollup is just another layer that extends the base layer, which is Ethereum.
It's like a super chain.
Yeah, it's like another mini chain on top of the mothership.
Okay. And okay, so I'd like to come to something that I read recently about you guys working with Visa, and because there's also a lot of chatter online about seed phrases and all that. So Visa is looking into ways to allow people to sort of chip from the same wallet, but like different users can chip from the same self-custody wallet. And it's doing so through something, it's looking into technology that's on StarkNet, right? And I believe it's called account abstraction. Yeah. So what is this? Again, please try to explain it to me as someone who is not really tech savvy, and I'm sure Max will have some questions around that.
So. I have zero knowledge. Prove it to me.
Great. So first off, we didn't work with Visa. Like they just one day showed up with this research,
Yes.
which I think is amazing because we want to be permissionless and we don't want to have to hold the hand of everyone who wants to work on StarkNet. So this to me was an amazing example of how everyone can interact with StarkNet freely, be it Visa or some developer who just graduated out of college and they have a cool idea that they want to implement. But this is true. Like they just put out a research or some article about a POC that they implemented that uses feature on StarkNet called account abstraction, which is basically about simplifying the user experience of users interacting with crypto. I think we all know that the UX of crypto today is pretty bad. Like it requires you to remember a seed phrase and then pretty often sign transactions that you don't really understand, which is, it's like such a crazy contrast between this and the UX that people have on traditional Web 2 experiences. And what account abstraction is about is like simplifying this experience. Because Ethereum is so restricted in its resources, they have a very strict format for how an account should look like. They define to you like how you should sign a transaction, how you should pay fees for this transaction. But when you operate in like a freer environment where things are, you can allow yourself to send more complex transactions and do it at a fraction of the cost of Ethereum, like StarkNet and some other rollups, you can move your account from the native Ethereum account to a smart contract account. And in this environment, you can go crazy with the way you sign transactions or pay fees. So for example, in a way that resembles more like the way we interact with Web 2 environments. Like, for example, what if I have my own wallet? I want to give you a free allowance to take $100 of my wallet once a week. Not more than that and not more frequently than that. You wouldn't be able to do it on Ethereum today. You'd have to write a smart contract for that. But operating the smart contract would cost you way more than $100. But on a system like StarkNet, you can go ahead, write a smart contract that implements exactly the same logic. So it could be about giving allowances or giving people a way to send repeating transactions or subsidizing the transaction fee on behalf of someone else. Let's say that I'm, CryptoKitties 2.0 on StarkNet. I want to encourage people or like new users to come to my app. So I could say, I'm funding the first $10 worth of transactions on my app. You can't do this on Ethereum today, but with account abstraction, you can. I hope that this was not too technical.
No, it's actually, it makes perfect sense. Yeah.
Can I ask a clarifying question though? So I guess, so essentially on Ethereum, you have like the account, like a wallet address that can like sign transactions. And then the only other thing that's possible, on Ethereum is like a smart contract. So you can either be an account or like an address or like a smart contract. But what you're doing then is using smart contracts to essentially make almost like a legal like entity that replicates what you would do with an account, being able to receive or send, and so much more because you're not limited by just the send receive functions of like a Ethereum wallet. Is that kind of correct? Yeah. It's
basically saying like on Ethereum you have like a preferred implementation of an account called an EOA, externally owned account. On StarkNet, we don't give you any like recommendation, or we don't enforce in the protocol any particular way of how your account should look like. Every account is a smart contract. You have this on Ethereum. You have like some smart contract accounts on Ethereum, like Gnosis Safe, which is pretty great. It's a good implementation of like a multi-signer account, but interacting with it is quite expensive. So it's being used just like to save significantly large amounts of value. It's like a very serious thing because every time you sign a Gnosis transaction, it costs you a lot of money. So it's basically taking this concept and putting it on a chain that has cheap transactions that are also fast. So you could make this magic accessible to more people.
And therefore possibly, inspire more innovation. Like if you then have the tools through like the smart contract to, you can kind of play with what the entities would be, like if I have a family account instead of us having like wallets, it could be like one thing, or, there's a potential that this would be able to open up, kind of like.
Yeah. So, there are many things that you can imagine in this area, but there's some things that have already been done on StarkNet, like Argent's work on social recovery. We have a few projects working on signing transactions with your phone, like having transactions signed on the secure enclave of your phone. So instead of requiring users to save their passphrase, they use the security mechanism of your phone to, exactly. Like you look at your phone and you sign a transaction this way. What Visa did is another example of this, and I'm sure that we're going to see like a lot more innovation in this direction.
Well, that wraps it on my end. Max, if you want to add something additional.
Yeah, no, I think it's a good place to stop. I should have gotten to it in the technical part, but I was curious. StarkNet is not, and this maybe can be cut out, but like StarkNet is not a zk Ethereum virtual machine, right?
It is not EVM compatible in the sense that the native language of StarkNet contracts is not Solidity or Viper. It does not compile to EVM bytecode. It's another language called Cairo, but it's a Turing complete language, which basically means that you can implement using this language, you can implement everything you want. So there's already a community effort of a project called Kakarot, which is about implementing the EVM in Cairo. So once this is implemented, we're going to have an EVM as an app on top of StarkNet. So does this mean that StarkNet is EVM compatible? Maybe.
So essentially, like if you were writing in Solidity, you could use like the app EVM, write whatever you want in Solidity, then that gets changed into Cairo, and then that goes back to Solidity.
Exactly.
Which I guess it works. But I guess I wonder what the kind of like limitations or strengths of being EVM compatible, like in kind of the traditional sense of like, okay, this is written in Solidity versus having your own, maybe more kind of like malleable or like useful language. But what are the like kind of limitations and strengths or strengths?
So I think the main reason why we didn't stick to being an EVM compatible chain is that we wanted to launch fast. That's like the main thing. Our mission is to scale Ethereum. It's not to create the best zk EVM, and through our experience and knowledge, we have like a deep conviction that the right way to scale Ethereum is not through being EVM compatible, because proving EVM bytecode is less efficient than proving what we have right now. Like if we like stick to the constraints of the EVM, our proving system would be less efficient. That's like one thing. But the other thing, which is the main thing to me, is that we just wanted to launch fast. So we launched with StarkX, where it was so hard to write smart contracts that we did it on behalf of our customers. But it works. Then we made Cairo more accessible, and we launched StarkNet. This was back in November 2021. So StarkNet is on mainnet for over a year now. And people started playing with Cairo, and they started realizing that you can do cool things with it, although it's not EVM compatible. And also there's this one project that I mentioned before that realized that you can implement the EVM in Cairo. So they kind of did it on our behalf.
Yeah.
Which I think is a better way to go. Like put things in the hands of developers as soon as possible and kind of like let them do what they want with it, instead of dictating to them that they should continue writing Solidity EVM compatible code.
Okay. So then, I guess that makes sense. And if you don't lose anything by, being not EVM compatible, or like, in that traditional sense, then
the one thing that you lose is that as a first step, you'd require people to translate their contracts from Solidity to your own language. But if they'd wait just a bit more, they could use Kakarot, they could use Warp, which is another tool that we have to sort of transpile Solidity code to Cairo. And also I think that if we kind of like invite people to rewrite their apps in Cairo, I am pretty certain that they would realize that with Cairo or with like with a native zk provable language, they could do more creative stuff than what they could have done on Ethereum with Solidity.
So I guess that's a good point, is that Cairo is a native zk proof language. So it's kind of that technology, everything that we discussed before, that's like embedded into the language, versus Solidity is not.
You can think of it like this, in Solidity, in the EVM, you have a lot of cryptographic primitives that are kind of hard to prove. They're not very zk friendly.
Okay, yeah, that was very interesting. I just trying to wrap my head around that, because to me it seems like, okay, zk EVM, that seems like it would be more efficient because it's like in that, it has the Ethereum virtual machine. But I definitely see your point about, having like just the kind of like especially having an EVM inside of StarkNet. I think it makes a lot more sense.
Yeah.
Well, Gal, thank you so much for this conversation. I think we managed to clarify some very foreign concepts to people who are not like particularly savvy in this type of technology, and we managed to drill down to the bedrock of the essence of what we discussed, and I think it was very informative, at least for me, for sure. Max, thank you as well for leading that part of the conversation.
I definitely feel like now I have a greater than zero knowledge about zero knowledge proofs.
Great. So nice chatting with you, and thanks for inviting me over.
Yeah, thanks so much.
Thank you.